तो आज अभी हम लोग पढ़ेंगे कि कैसे रीज रिप्रेजेंटेशन थ्योरम प्रूफ होता है। ठीक है, रीज REISZ रीज रिप्रेजेंटेशन थ्योरम। ठीक है, ये क्या कहता है? सबसे पहले तो इसका हम लोग क्या देखेंगे, स्टेटमेंट देखेंगे। तो स्टेटमेंट कहता है कि एवरी बाउंडेड linear functional every bounded linear functional for Hilbert space H can be written as इसको हम लोग क्या बोलेंगे और कैसे लिखेंगे? written as f of x which is equal to just represented by x comma some z. What is z? Actually z is depends on f. Z depends on f and uniquely determined by f, right? Determined by f, right? Also we can write what? That the norm of f which is equal to norm of z. Okay, so now we are going to just prove here, है ना? So the statement, just see the statement, right? What it says? It says that every bonded linear functional, right? You know, everyone knows the bonded linear functional for Hilbert space, right? And it can be represented as, that means the function f of x can be represented as this x is here, x as inner product of x comma z, and z is what? Z is actually depends on the functional f. F is nothing but a functional, right? And which is uniquely determined by funcs what? Z, right? So now we are going to prove it. So prove. How we will prove? Okay, so just prove. Now there are actually the two cases. Let us suppose say first case, and the case number 1 is if f is identically 0, then what will happen? Then z must be equal to 0. You can see that if f is identically 0, then z must be identically 0. Dekho, if, and the last property is also the norm of f, that will be equal to norm of z, right? So the conclusion is basically trivial. Conclusion is trivial. What? Trivial. Okay, now next, the second case is if f is not identically 0, then what will happen? Then null space of f, the null space of S is not equal to the whole space, that is the Hilbert space, right? And also n of f, that is the null space of f, is actually closed. Yes, always closed in actually closed, not closed subspace, right? Closed subspace of H of the Hilbert space. So what we can write, that null space of f is not equal to 0, singleton 0, right? So this is fine. Okay, so n of f is not equal to 0. That means the null space had some element. So now let us suppose, let suppose say v which is not equal to 0, right? and that V is belonging to the null space of F complement, right? Null space of F complement. Suppose this is the Hilbert space, right? This is the Hilbert space, and suppose say this is null space of F, and this is null space of F complement, right? So we know that this Hilbert space is not equal to the null space, but null space is also not empty. Okay, so let us suppose say V is an element of null space of complement of null space, then we can define here, right? So let us suppose define what T, that is nothing but equal to x times f of V minus V times f of x, right? F of x. Here you can see that this value is belonging to R, that belonging to the real number. This is also belonging to the real number, right? Belonging to the real number. So what we can say about this now, if we apply the function that is f of t on both sides, right, then we got the value that is x. So f of x, f of v minus v, f of x, right? Then what will happen? F of t, that will be equal to, we can write this one as f of v, because this is a constant term, right? So it will go outside, and this x is come under f of x, right? So minus, and we can write again this one. So f of x, that is equal to f of x into f of b, right? So actually this and this both are same value, so f of t, that will be equal to 0, cancelled out, and then the remaining value will be f of t equal to 0. This implies that T belonging to the null space of F, right? Yes, there is a, so what we can say that, so V, that belonging to null space of F, complement of null space of F, and T is belonging to the null space of F here from here. Yes, we can write. So this implies what? The inner product, what is this? Is an element that belonging to the complement of the null space and element that belonging to the null space of F, and these both are the perpendicular, right? Perpendicular complement. So we can say that both are perpendicular to each other. So the inner product of V comma T is nothing but equal to 0. So we can write that inner product of x into f of b minus b into f of x comma b, because the value of b is value of t is this, and the value b is that, we can write like this, right? So this is actually t comma b. Now this will be equal to 0, and after that, because this is the constant value, so take it common outside this inner product, right? And this is x comma b, and this is also the constant value, right? So minus function of x and of b comma b, right? That will be equal to 0. So here the function of x, if we take if you find the value of f of x, that will be equal to, it gives f of b divided by norm of b, right? A square and x comma b. Okay, and next what will happen? This value actually will be equal to inner product of x comma f of b bar upon norm of b square to b, right? So this is the inner product. Okay, so from here we can write what, that let z will be equal to, where we can say z is equal to f of b bar upon norm of b square, right, into b. So prove. So this will be equal to x comma b, sorry, x comma z, right. So now we need to show what? We need to show that uniqueness actually, right? Here now we need to show the uniqueness of z, right? So for this we have to take another piece, right? So for uniqueness of z, if possible, let function of x that will be equal to x comma z1 and f of x that will be equal to, and the second one is suppose say x comma z2, right? So this implies function or suppose say subtracting 1 in the system, 1 subtracting 2 from 1. So क्या मिलेगा? Then we get what? Nothing but x comma z1 minus z2, that will be equal to f of x minus f of x. So this will be equal to 0, which is nothing but for all x belonging to h. So now take x is equal to z1 minus z2. Okay. So this implies z1 minus z2 comma z1 minus z2, that will be equal to 0. And from here we can write that this is norm of z1 minus z2 whole square, that will be equal to 0, and this implies z1 minus z2, right, is equal to 0, and this implies z1 is equal to 0. But there is a condition that if we take the value of x which is equal to z1 minus z2, right? So this implies we can say z is unique and depends on f, right? So